Hi, sir.
Hi, good afternoon to all of you. How are you all?
I am Bhaskar, sir. Just a minute. Connect.
Yeah, good afternoon, Bhaskar. How are you, sir? Is my voice audible clearly, sir?
Yes, sir. Sir, am I audible?
Yes, sir, you are audible.
Audible to you? Am I audible to you, Shankar?
Yes, you are audible.
Okay, fine. Second, I think there is an issue in this speaker connectivity. Just 5 minutes. Yeah?
Yeah, it is a little bit now fine.
Yes.
Is it audible now? Is it audible now? Release. Okay. So, now, sort of 2 minutes. Am I audible now?
Yes, sir, you are audible.
Okay, is it clear now? My voice clear or is it breaking?
Yeah, it is very bit little cracking, but it is audible.
Okay.
Keep the laptop nearby. So they will validate work, within this issue. Okay, cool, I'm in a class. Can you speak? Are we audible now?
Yes, it is now clearly audible.
Okay. So for today, please work on this. So that at least you can follow the plan. Please make sure the discussion is interactive. Talk and ask questions. Like you have to talk first. Yes, sir, you can please take over this.
Okay, sure. So dear students, how are you? Is my voice clearly audible to you? Can you hear me? Is my voice audible to you? Yes, can you hear me? Is my voice audible to you? Yes, yes, tell me. Your voice is not clearly audible to me. Okay, no problem. I hope that you have gone through the basics of chemistry. That is the first chapter. That is some basic units of basic concepts of chemistry, right? So let's start with the second chapter. That is the atomic structure. That is the structure of atom, right? So we have already studied in the first chapter. You have already gone through the Dalton's atomic theory, right? And the modern atomic theory, isn't it? In that theory, we have seen that every matter is made up of atoms, right? So now in this chapter, that is the structure of atom, we are going to study in detail the structure of atom, what are the various subatomic particles which are present there inside the atom. Similarly, their discovery we will study, the various atomic models we will study, that is the Thomson's model, Bohr's model, Rutherford's model, isn't it? The modern concept of atom. So before starting, I'm again repeating that atom, it is actually derived from a Greek word atomos, which means indivisible. So according to Dalton, atom is indivisible. It cannot be further divided. But in the end of the 19th century, the various particles got discovered which are actually present inside the atom, like the electron, proton, and the neutron, which are known as subatomic particles. So let me share the screen, whiteboard, then I will write there. I hope it is visible to all of you. So can you see this whiteboard? I have just shared the screen. So let's start here. We are having the atomic structure. So in this chapter, we are going to study the discovery of 3 subatomic particles, which are very important. So first of all, I'm again repeating the basic that before we had discussed the Dalton's atomic theory. So in which Dalton told that atom word, it has actually been and derived from the Greek word that is your atomos. So which actually means indivisible, right? So atom cannot be divided further, it's indivisible. But later we find that this atom, it is further made up of 3 subatomic particles. Atom is having actually the complex structure. Atom has complex structure. It is further made up of 3 subatomic particles, which you already know. One is the electron, another is the proton, and similarly the neutron. These are the 3 main subatomic particles which are actually present inside the atom. So these subatomic particles, they got discovered in the end of the 19th century by the various scientists. Like electron, it was discovered by J.J. Thomson. We will see it in detail. Similarly, proton, it was discovered by Goldstein. And similarly, the neutron, it was discovered by this Chadwick. So now how actually we came to know that actually every matter, it is made up of electrons. So it was actually, you know that when a glass rod, if we are having a glass rod and it is just rubbed with, when a glass rod, it is rubbed with silica or fur. So what happens? It becomes charged, right? So that means now this glass rod, it becomes charged. There is actually production of static electricity. That means electrons are produced there, it becomes charged. Similarly, you have already seen that if we are having a comb, isn't it? If we are having a comb and we are just rubbing it with dry hair, it also becomes charged and it can attract the small pieces of papers. So when comb is rubbed with dry here, what happens? It becomes charged. And when it becomes actually charged, so that means it can now attract small pieces of papers. So that means every matter, it is actually made up of some charged particles. And what are those? Those are actually the electrons. And these electrons, they were discovered by J.J. Thomson. We will see it in detail. But before going to the experiment of discovery of electron, it was Faraday. We will study ahead in class 12 the very two important laws of Faraday, known as Faraday's first and second law. So in Faraday's laws, actually, Faraday, what he did, he carried out electrolysis. I hope you have gone through this topic, electrolysis. It's very important process which is actually carried out when we pass the electricity through the electrolyte, isn't it? For example, if we are having this container, and let's say I'm here having the molten NaCl. So Faraday, he took this sodium chloride in the molten form. Are you getting me? Is it clear? So molten NaCl, it was taken here in this beaker or container. What we call it as, actually, it is known as electrolytic cell, in which electrolysis is carried out, isn't it? Electrolytic cell. So now what he did, he just took the two electrodes, which is one is your known as cathode, another is known as electrode, and he just passed the electricity. So you have to remember that we are here having two types of electrodes. One is your cathode. Cathode here, it is your negative pole. It's connected to the negative terminal of the battery. And let's say this one is your anode, and this is connected to the positive terminal of the battery. So can any one of you tell me what is actually anode and what is cathode? What are these? How can we define them? Can you tell me?
Cathode is positively charged ray and anode is negatively charged.
Okay, you have studied this, but actually it is not the correct way to define. You have to remember that anode is that electrode on which oxidation takes place. This is the correct definition. Okay, you will write it down because this is very important. Because, for example, if you remember it on the basis of charge, for example, I told here that anode is positively charged. But when we will study the cells, that means the dry cell, we are having different types of cells. There I will tell you that anode is your negative pole. So that doesn't mean that anode, it can be sometimes positive pole, sometimes it is treated as negative pole. So you have to remember that anode is actually, I will write it here, that anode is that electrode on which oxidation takes place, on which oxidation takes place. So when oxidation takes place on any electrode, that will act as your anode. Now you already know what is oxidation. I hope you have gone through this. Oxidation means loss of electron. When some metal rod, it will lose electron, it will when there is loss of electron, so we call it as oxidation. And oxidation will act, anode will act as your anode. Anode will, there will be oxidation on the electrode, anode, and similarly cathode is that on which reduction takes place. So you will write here that cathode is that electrode on which reduction takes place, that electrode on which reduction takes place. Now what will be the reduction then? So reduction means gain of electron, isn't it? Reduction means gain of electron. So now here we have seen that we were just having, I will again show it, the first slide. So you can see here that cathode, it is my negative pole. Why? Because actually on cathode there is reduction. Reduction means gain of electron. If some atom gains electron, so there will be negative charge on that. So that's why it is here your negative pole. And similarly, anode is that on which oxidation takes place. So oxidation means loss of electron. And when some electrode loses electron, so that means it will become electron deficient. So there will be positive charge, isn't it? So then what Faraday observed here, Faraday observed that what happens here when we pass this electricity through this molten NaCl, he observed that there is liberation of chlorine gas here at the anode, and there is deposition of sodium on this cathode. So this cathode, there is deposition of sodium. So sodium gets here deposited. Deposition of sodium. Deposition of sodium. And there is liberation of chlorine gas, right? Liberation of chlorine gas. So with this electrolysis, Faraday told that actually this electricity which we are passing, it is made up of some particles known as atoms of electricity. So when Faraday passed the electricity through this molten NaCl, it acts as your electrolyte. So molten NaCl, it here acts as your electrolyte. So electrolyte is actually any substance. It can be your salt, it can be your acid, it can be your base, which actually decomposes when we pass the electricity through it. So when we pass the electricity, okay, let me tell in detail what actually happens here. For example, here, when we pass the electricity, what will happen? This NaCl, it will decompose into ions, right? It will ionize. So I will get Na positive and I will get the Cl negative ion, right? So now, which ion will move towards which electrode? So this is Na positive. So it will definitely move towards the cathode because cathode is your negative pole, isn't it? Unlike charges attract each other. So similarly, this Cl negative, it is your negative ion. So definitely it will move towards the anode because anode is your positive pole here, acting as a positive pole. So let's see then the reactions, what actually happens here in case of the electrolysis of NaCl. So let me write it here that at anode, let's say first at cathode, there will be reduction, isn't it? I told that at cathode, what happens? Reduction takes place. So which ion has actually moved towards the cathode? It is your Na positive ion, right? So Na positive, it is at your cathode, and there will be now reduction. Reduction means gain of electron. So when this Na positive ion, it will gain electron, it will become your sodium solid. So that means this sodium, it will get deposited on cathode. So how we actually know that it gets deposited? Because the weight of cathode, the mass of cathode, it increases. So similarly, what will happen at anode? I told that at anode, there is oxidation. So oxidation takes place at anode, and I told that oxidation means loss of electron. And I told also that at anode, there will be which ion? There will be Cl negative ion, because Cl negative, it is your negatively charged ion, it is your anion. So it will move towards the anode because anode is your positive pole acting here. So what will happen? Oxidation will take place. So that means it will lose one electron. Loss of electron means oxidation. So when this Cl negative, it loses one electron, it will form chlorine atom, but chlorine atom is unstable. It will react with another chlorine atom. So it will just liberate in the form of chlorine gas. So is it clear up to this?
Yes, sir.
Okay, that's fine. So if you are having any doubt, any question, you will just tell me there, right? If you are not able to understand properly any point from this, any line, so then just let me know, then I will explain it in very easy manner. So now from this electrolysis, what Faraday observed? Faraday observed that when we pass the electricity, there is a deposition of sodium and there is liberation of this chlorine gas. So chlorine gas, it gets liberated because gas, it will move out of the electrolytic container, electrolytic vessel. So he told that electricity, it is made up of some particles, which he told as atoms of electricity. So he told that electricity, it actually contains some particles known as atoms of electricity. Okay, I will write it on the next page that he told that electricity, it is made up of some particles known as atoms of electricity. Atoms of electricity. Now, what are actually these Is my voice audible?
Yes, sir.
Okay. So I told that according to Faraday, atoms of electricity, but we know now that these atoms of electricity, they are actually your electrons, isn't it? What is actually electricity? It is the flow of charge, it is the flow of electrons. So actually atoms of electricity are electrons, but these electrons, they were not discovered by the Faraday just have this electrolysis, and he told that electricity, it is made up of atoms of electricity. But this term electron, so can anybody tell me that this term electron, it was coined by who? Coined this term?
JJ.
No, J.J. Thomson just discovered this electron, but who coined the term? Term electron was coined by, I will tell you, it is G.J. Stoney. So it was the Stoney who coined this term, that he called these atoms of electricity as electrons. It was G.J. Stoney. I hope you will remember the name. It was G.J. Stoney. It is the talk of 1875. So in 1875, G.J. Stoney, he told that this electricity, it is made up of particles, which are actually not the atoms of electricity, what was told by the Faraday. He told that these atoms of electricity, they are your electrons. So G.J. Stoney coined the term electron. Now, how these electrons, they got actually discovered? So it was the first experiment done by William Crookes, which is known as cathode ray discharge tube experiment. So I will write it here. So now let us see, you will write the heading, the discovery of electron. Discovery of electron. Because the first topic of this chapter, of this unit, it is your discovery of subatomic particles. That is your electron, proton, neutron, right? So we have to go through accordingly. We will go accordingly. So first, let's see the discovery of electron. So electron was discovered by an experiment known as cathode ray discharge tube experiment. Cathode ray discharge tube experiment. Cathode ray discharge tube experiment. So this, can anybody tell me among you that this cathode ray discharge tube experiment, it was carried out by who? Who did this experiment? Can anybody tell me who did this experiment, cathode ray discharge tube experiment?
JJ Thomson.
No. It was not the J.J. Thomson. So it was William Crookes. It was first William Crookes who carried this experiment. Then actually the credit goes to the J.J. Thomson. That is later. I will tell you in detail that how actually credit goes to the J.J. Thomson. But the experiment of cathode ray discharge tube experiment, it was carried out by William Crookes. It is the talk of 1878. So what William Crookes did? William Crookes, he took a discharge tube, a glass tube. I hope you have gone through this in lower classes. So it was just nearly 50 to 60 centimeter in length. I will show it here. So can you first of all tell me that is gas good conductor of electricity or bad conductor? Can you tell me, is this gas, any gas, is it good conductor of electricity or bad conductor of electricity? Gas is bad conductor of electricity, isn't it? Am I audible? Can you hear me?
Yes, sir. Yes, sir.
Yes. So what I told that gas, any gas, let it be hydrogen, nitrogen, carbon dioxide, any gas, it is bad conductor of electricity. Now what William Crookes did, he took just this glass tube. It is just a glass tube which was having 50 centimeter in length. Now he took the two electrodes inside it. I hope you now know the electrodes. Electrode is nothing but a metal rod which can just conduct the electricity. So one was your just cathode, another electrode was your anode, isn't it? So can you now tell me what is your anode and what is your cathode? Can you tell me, for example, if it is my here negative, so what I will call it as? It is your cathode, isn't it? I told that cathode is that electrode on which reduction takes place, isn't it? So this was connected to a battery here, which was having very high voltage. So this is the positive terminal of the battery, and here it is the negative terminal. And this is my anode here, positive pole. Anode will act here as positive pole because I told that at anode there is oxidation taking place, right? So oxidation, what it means? It means loss of electron. So when anybody loses electron, so there will be positive charge on that because it is now becoming electron deficient. And similarly, on cathode there will be reduction. Reduction is the gain of electron. So that means whenever any species will gain electron, it will become electron rich. So that's why it is given negative sign here. Now what I told that any gas, it is bad conductor of electricity, isn't it? But now what William Crookes did, he changed some conditions and he make this gas good conductor of electricity. So
Sir,
this was
low
very
pressure.
important.
At low pressure.
Exactly. The pressure was low, and how he decreased the pressure with the help of vacuum pump. So he connected here the vacuum pump. With the help of this, pressure was decreased. How much pressure was decreased? Can anybody tell me? It was 10 raised power minus 4 atmosphere, right? Pressure unit, we are having various units to express the pressure. For example, pressure can be expressed in atmosphere. Similarly, the Pascal is the SI unit of pressure. Similarly, bar is another unit. So I'm just here using atmosphere. ATM, it is the atmosphere unit of pressure. Now, what he did, he connected here HT battery, that is high tension battery. So high tension means which is actually giving here very high voltage. So the voltage of this battery, which he connected, it was 10,000 volt, right? Yeah. So now what he observed that there are some rays coming from this cathode and they are now moving towards this anode. And now these rays were known as cathode rays. This was the experiment done by the William Crookes, and he observed that when pressure was decreased and when voltage was increased, what happened? There is flow of some rays, some particles are observed flowing from cathode towards the anode. And now how it was seen, how it was observed? It was observed because here actually what William Crookes did, he just have here the fluorescent or phosphorescent material which was coated here. For example, this glass surface, it was just coated with some zinc sulfide screen. So zinc sulfide, it is your fluorescent material, or what we call it as phosphorescent material. Fluorescent material is that material when some particle strikes on this, it starts glowing. So what he observed that when some holes were created here in this anode, and through these holes, these rays, they just passed through this and they just strike it here. And when these rays, cathode rays, they strike this zinc sulfide screen, what he observed that it started glowing. So this zinc sulfide screen, it started glowing, so there is a bright spot was produced here, so which clearly indicates that some particles are now coming from the cathode towards the anode, and these rays were known as cathode rays. So this was the cathode ray discharge tube experiment done by William Crookes. Have you got up to this any doubt, any question?
No, sir.
Is it clear?
Yes, sir.
Okay, so that means we have understood that gas is bad conductor of electricity. It doesn't conduct electricity under normal conditions, but if we just decrease the pressure, so these are the two conditions. We can make gas a good conductor if we just decrease the pressure and if we just increase the voltage, isn't it? If we increase the voltage of the battery, if we are just connecting the HT battery, that is the high tension, here voltage we are having 10,000 volt. So that means at this voltage and at this very low pressure, what William Crookes observed, he observed that some rays are coming from the cathode and they are moving towards this anode. And when they actually, these rays, they strike this zinc sulfide material, zinc sulfide screen, it started glowing. So there is production of bright spot. So it indicates that some particles are coming from the cathode, they are moving towards the anode. So that means this gas now becomes good conductor. Now these rays were known as cathode rays. Now these cathode rays, they were studied by J.J. Thomson in detail. So I'm again repeating that William Crookes did the experiment, but the cathode rays which were seen here, their properties were studied by cathode ray. Yes, any question? Any doubt? Shall we move ahead? Any doubt you are having? Okay, now I will write here the properties of these cathode rays. Properties of cathode rays. So these cathode rays, their property, it was studied by J.J. Thomson. J.J. Thomson. So that's why actually the credit goes to this J.J. Thomson, right? So what was the first property? First property which he studied was that these cathode rays, they travel in a straight path. So I'll write it here, that cathode rays travel in a straight path. Is it clearly visible on the screen? So these cathode rays, they travel in a straight path. So how he told it? Actually, what he did, J.J. Thomson, he took these cathode rays and he placed a solid object inside these cathode rays. For example, these are the cathode rays which are actually moving from cathode towards the anode, right? Now what he did, J.J. Thomson, he just placed here a solid object like this. Let's say this is any solid object. And what he observed that, let's say here it was our glass screen. He found that there is some shadow formed behind this, isn't it? Shadow of the object. So shadow clearly indicates that these cathode rays, they travel in a straight path, just like our light. Do you know that light travels in a straight path? Isn't it? Can you hear me?
Yes, sir. Yes.
Yes, so light travels in a straight path because when any solid object is placed in light, what happens? The shadow is formed behind that. So same is the case here, that in case of these cathode rays, when we place any solid object in between these cathode rays, shadow is formed behind. So it clearly indicates that these cathode rays, they travel in a straight path. Now the next property of these cathode rays, which was studied by J.J. Thomson, that is that these cathode rays, they are made up of material particles. Cathode rays are made up of material particles. So what do you understand by this material particles? Material particle here means that they have mass. That means cathode rays, they contain such particles which are having mass, right? So how it was observed? It was just observed by this. I will just show it again, the cathode rays here. Let's say these are our cathode rays. And what he did now, he just placed a light paddle wheel here. So let's show it like this. So let's say this is my light paddle wheel. Light means which is having very low density. Light paddle wheel. And when he just place it, okay, if you can remember that this light paddle wheel, it is made up of mica. Mica, it is your aluminum silicate. Aluminum silicate. So this is your light paddle wheel, and when he just placed this light paddle wheel inside this inside these cathode rays, what he observed that it started rotating. So rotation is possible only that if these cathode rays, they are made up of material particles. That means such particles which have some mass. Because for example, if it was light, so can you tell me that if light falls on this light paddle wheel, will it start rotating? No, it will not start, because light is only made up of energy. It will start rotating only when some particle strikes here. For example, some heavy particle here, it is striking this light paddle wheel, so then it will start rotating. So that is why he concluded that these cathode rays, they are made up of material particles. Got it? So this was the second property of these cathode rays. Then another property which was very important, which observed here, that was that, for example, if these cathode rays, they are just given the electric field. Let's say these are my cathode rays here. Now here, let's say we are here connecting a positive plate connected to the positive terminal of the battery, and here another one, that is the negative plate connected to the negative terminal of the battery. So there will be now production of electric field. Now what he observed, that these cathode rays, they just got deflected towards which plate? Towards the positive plate. Now, why they got deflected towards the positive plate? It clearly indicates that these cathode rays, they are made up of negatively charged particles, isn't it? Because unlike charges attract each other, right? So there are negatively charged particles in these cathode rays. That is why it is just, they are just getting deflected. They are just bending towards which plate? Towards the positive plate. So the third very important observation was that these cathode rays, they are made up of negatively charged particles, and they were known as electrons. So this was the discovery of electron. So I will write it here, that cathode rays are made up of negatively charged particles, negatively charged particles known as electrons. So that is why credit actually goes to the J.J. Thomson. Otherwise, the experiment was first done by William Crookes, but the properties of these cathode rays, they were studied by J.J. Thomson. So that's why credit goes to J.J. Thomson. So he told that these cathode rays, they are made up of negatively charged particles, which actually get deflected towards the positive plate. And similarly, you can also give the magnetic field. If you just take the north and the south pole of the magnet, you can also observe that these cathode rays, they are made up of negatively charged particles. So they were your electrons. Now, the very important property was that if we just take any gas, it doesn't matter which gas we are taking inside the discharge tube, whether it is hydrogen gas, nitrogen, oxygen, or carbon dioxide. In all the cases, we will get these cathode rays, and all these cathode rays, they are always made up of negatively charged particles. They are your electrons. So that means I can just say like mass and charge, mass upon charge ratio, it doesn't depend on the nature of gas. So I will write here that I will write like this, that is charge upon mass ratio does not depend on nature of gas. So what do you mean by this? It means that whether you are taking hydrogen or nitrogen or any gas, the charge upon mass ratio of these cathode rays, it will always remain same. So that's why I told here that charge upon mass ratio, it doesn't depend on nature of gas. Which gas you are taking? In all the cases, electrons will be produced. Cathode rays will be produced. Okay, next very important phenomena, that was these cathode rays, whenever they pass through any gas, that gas gets ionized. Yes. They ionize the gas through which they pass. Do you know ionization? For example, if I'm having hydrogen gas, if just I'm passing through this hydrogen gas, I'm passing these cathode rays, it will just ionize. For example, let's say it will become H2 negative. Ions will be formed here. So gas gets ionized when we pass the cathode rays through this. Next property of these cathode rays is that these cathode rays, when they strike any metal surface, that gets heated up. So they cause heating effect. See, so I will write here that they cause heating effect when they strike any metal surface. So they cause heating effect when they strike a metal surface. Correct? For example, if you are having any metal surface like iron, like aluminum, like copper, when these cathode rays, they strike this metal surface, that metal surface gets heated up. Next very important property you can write here, that is these cathode rays, when they just actually strike the photographic film, it affects that. So that phenomena is known as fogging. So I will write here that they affect the photographic film. They affect the photographic film which is known as, this phenomena is known as fogging. So I hope you will remember this term, that is fogging, F-O-G-G-I-N-G, fogging. This is actually when any cathode ray, it strikes the photographic film, so that photographic film gets affected. There is some spot produced there. So that is known as fogging. So have you got all these properties of cathode rays? Any doubt here? So is it clear up to this?
Yes, sir.
So have you written down this?
Yes, sir.
Okay. Now I will just here repeat everything which we have studied up to this, right? Can you hear me properly?
Yes.
Yes.
Okay, so see what we started from the structure of atom. I told that atom, it was told that it is indivisible, but in the end of the 19th century, it was observed that there are some particles inside the atom. It can be divided further. It is having the complex structure. It is made up of 3 subatomic particles. One is your electron, proton, and neutron, right? So how it was actually seen? I told that whenever a glass rod, it is just rubbed with a slick or with a fur, it gets charged. There is actually production of charge, that is known as static electricity. Or similarly, when, for example, we are having any dry comb and we are just rubbing it with the dry hairs, it becomes charged. It can attract the pieces of paper. So that means any matter, it is actually made up of electrons, charged particles. So how these charged particles, they actually got discovered? They got discovered, first it was, I told that the experiment, that is the electrolysis, it was carried out by the Faraday. Faraday observed that whenever we pass the electricity through molten NaCl, that is sodium chloride solution, what happens? There is production of chlorine gas at the anode and sodium gets deposited at the cathode. So this experiment showed Faraday, Faraday told that actually electricity is made up of some particles known as atoms of electricity. He was not knowing at that time that they are actually electrons. So he told it just atoms of electricity. Then I told that this term electron, it was coined by G.J. Stoney. And after that, it was the William Crookes who did the experiment, which is known as discharge tube experiment or cathode ray discharge tube experiment. What he did, he just took a gas inside the glass tube, which was nearly 50 centimeter in length. And then what he did, he just decreased the pressure up to 10 raised to power minus 4 atmosphere, and he increased the voltage of the battery up to 10,000 volt. And what he observed, that there are some rays coming from the cathode and they are moving towards the anode. This is very important. The rays are moving from cathode towards the anode. And I told that cathode is that on which reduction takes place, and anode is that electrode on which oxidation takes place. And then these rays were known as cathode rays. And how actually William Crookes got this, that there are some rays coming from cathode towards the anode. He actually placed some fluorescent material, that was the zinc sulfide screen here, which was coated on the glass surface. And when these cathode rays, they struck the zinc sulfide screen, it started glowing. It just produced the bright spot. So which indicates that there are some rays coming from the cathode and they are moving towards the anode, and these were known as cathode rays. This was the experiment done by the William Crookes. Then after that, the properties of these cathode rays, they were studied by J.J. Thomson. That's why credit goes to the J.J. Thomson, because he studied in detail the properties of these cathode rays. One property was that these cathode rays, they travel in a straight path. They do not bend, they do not deflect when they are just moving without any electric field. So they are just passing straight. How he told that? He told that whenever a solid object is placed in these cathode rays, its shadow gets formed behind. So whenever there is formation of shadow, it clearly indicates that these cathode rays, they travel in a straight path. Second property of these cathode rays, that was that these cathode rays, they are made up of material particles. That means such particles which have some mass. How he told that? He just placed a wheel, a light pedal wheel, which was made up of mica. I told that mica is made up of aluminum silicate. So that's very light, that's having very low density. So when these actually cathode rays particles, that means these electrons, actually when they strike this light pedal wheel, it started rotating. So it clearly indicates that these cathode ray particles, they are charged, they are having some mass, they are materialistic in nature. So that's why he told that cathode rays are made up of material particles. Now, when these cathode rays, they were just given the electric field. So how electric field is given? We are just having the two plates. One is connected to the positive terminal of the battery. Another is connected to the negative terminal of the battery. Then these cathode rays, they were just passed between these two plates, and they got deflected towards the positive plate. Positive plate indicates that they are actually made up of negatively charged particles, because we know that unlike charges attract each other, isn't it? Unlike charges attract each other. So that is why these particles, they just got deflected towards the positive plate, indicating that they are itself made up of negatively charged particles. So these negatively charged particles, they were known as electrons. So that's why we say electron was discovered by J.J. Thomson, right? So it is the talk of 1897. Electron was discovered by J.J. Thomson in 1897. Now, what were the other properties? I told that charge upon mass ratio of these cathode rays, it remains constant. It doesn't depend on the nature of gas. Whether you are taking hydrogen gas, nitrogen, or any gas, it will always produce these cathode rays, and they will have same charge upon mass ratio. Next, I told that these cathode rays, whenever they strike any metal surface, it gets heated up. It causes the heating effect. Another, I told that whenever it strikes the photographic film, it affects that phenomenon is known as fogging. And similarly, if these cathode rays, they are just passed through thin foil of aluminum, they will pass through that. But if aluminum foil is thick, then they cannot pass through that. So this is another property, you can write it there. Similarly, when these cathode rays, they just strike the zinc sulfide screen, what happens? It starts glowing. So that phenomena is known as fluorescence or phosphorescence. Got it? Any doubt, any question you can ask? You should have questions, because unless and until you will not ask questions, how you can understand any particular point? Just try to ask questions. Now see here that after we have studied the properties of these cathode rays, then the two very important discoveries were there. That is, one was charge upon mass ratio of these electrons, it was found. And similarly, the mass of electron was found and the charge of electron. So can you tell me who actually found the charge upon mass ratio of electron? Charge upon mass ratio. Can you tell me that charge upon mass ratio of electron, it was found experimentally by which scientist? It was the Sam J.J. Thomson, right? So, okay, let me share the screen and tell in detail that how charge upon mass ratio was found here. And similarly, how charge was found, and similarly then the mass of electron. They are very important three properties of these electrons. So let me share it here. So see, I will write it here that charge upon mass ratio. Charge upon mass ratio. So charge upon mass ratio, it was experimentally found by the Sam, that is J.J. Thomson. Now, what he did actually, see, for example, if we are having this cathode ray, if I'm having this cathode ray, and now just I'm giving the electric field here. Let's say this is my positive plate connected to the positive terminal of the battery. And let's say this is my negative plate here connected to the negative terminal of the battery. Now, here it was the fluorescent screen, that is the zinc sulfide screen, with the help of which you can just see that where, at what point, at what place these cathode rays will strike. So this is my cathode ray and I'm passing it through this electric field. So now it was observed that it will just strike here, let's say at point E, right? Now what J.J. Thomson also observed, that for example, if we are giving only the electric field, they will strike at point E. But now if, yes, are you having any question? So is it clear that this cathode ray, it will strike at point A here? Because it will just get bent towards this positive plate, right? Okay, now see, if now I'm just giving the magnetic field, let's say I'm just giving magnetic field at a perpendicular direction. Let's say here it is the south pole of the magnet. And let's say here I'm having the north pole of the magnet, right? So I'm just giving the magnetic field. So if I'm just giving the magnetic field, then these cathode rays, they will strike, let's say at point B. If I'm just giving only the magnetic field, if I'm just giving only the electric field, then it will strike at point A. And if now I'm giving the magnetic field, then it will strike at point B. But What he did now, J.J. Thomson, he just balanced these two fields, that is the electric field and the magnetic field. And he observed that if we just balance these two fields, then it strikes at point C, just as it was just passing straight. So by balancing the strength of electric, by balancing the strength of electric and magnetic field, what he observed that the charge upon mass ratio, that is represented by E upon M, charge upon mass ratio, it is represented by E upon M ratio. So E upon M ratio, that is charge upon mass ratio, it was found to be 1.67 into 10 raised power 11 coulomb per kg. Isn't it? Because actually the unit of charge, that is the coulomb, and the mass unit, that is the kg, correct? So this was E upon M ratio. It was found by J.J. Thomson. Actually, see, there are the three factors on which deflection depends. See, for example, first is the charge. Higher the charge on particle, more will be the deflection. So that means deflection is directly proportional to the charge. So more the charge on the particle, more will be the deflection. It was the first point. Second, yes. Any question, any doubt here? So next he told that is the size. Smaller the size, more will be the deflection. So that means size is inversely proportional to the rate of deflection. So smaller the size, more will be the deflection. Next point, the third, that was actually the strength of electric or magnetic field. Strength of electric field. If electric field strength is very high, then the deflection will be also high. It is also directly proportional. So more the strength of electric field or more the strength of magnetic field, more will be the deflection. So on the basis of these three factors, what he did, he just balanced the electric and the magnetic field, and he observed that these cathode rays, they travel straight and they strike it at this point C. And by balancing these two fields, electric and magnetic field, he just find out this E upon M ratio, and it was found to be 1.67 into 10 raised to power 11 coulomb per kg. So this was charge upon mass ratio. Have you got this? So then was the discovery of charge. So can you tell me how charge got discovered? Charge of electron. Charge of electron, it was discovered by another scientist that is known as R.A. Millikan. R.A. Millikan. So he discovered the charge of electron by an experiment known as oil drop experiment. Oil drop experiment. And the charge of electron, it was found to be minus 1.602 into 10 raised to power minus 19 coulomb. Right? I'm again saying that the charge upon mass ratio, it was discovered by J.J. Thomson by just balancing these two fields, that is the electric and magnetic field. But the charge of electron, it was found by R.A. Millikan by an experiment known as oil drop experiment. Now, what is actually here happening in this oil drop experiment? Let's see on the next page. In this oil drop experiment, you will remember that R.A. Millikan, he just took the apparatus was like this. So there were actually two plates, metal plates. One is connected to the positive, another to the negative terminal of the battery. Let's say this is my positive plate, above one, and this one is my negative plate here. Now oil was just passed here through an apparatus known as atomizer. So here it was just oil here. Oil was passed in the form of mist here. So yes, atomizer. This is known as atomizer. It is an apparatus which will just throw this oil here in this apparatus in the form of mist, oil in the form of mist. Oil in the form of mist. So that means very small, tiny droplets of oil, they were just passed here. And now here it was the very small hole in this positive plate. Now these oil drops, they will just fall from this. And now here X-rays were passed, X-rays. When X-rays are passed here, it was the gas here and it got ionized. So when there is ionization of the gas, so that means there will be production of charge, electrons will get liberated here, and these electrons, they will be now taken by these oil droplets. So these oil droplets, they just take the charge from this ionized gas, and these charged particles, they were just seen here with the help of telescope. Let's say this is your telescope here. So now what R.A. Millikan observed here, that the charge of these oil drops, so oil drops, they become charged. Charge of oil drops, it was found to be Q is equal to N into E. So what is the Q? Q is the charge of oil drops, and N is any integer. Its value can be 1, 2, 3, etc. And E is the charge of electron, and its value I already told, it was found to be charge of electron. Its value was found to be minus 1.602 into 10 raised power minus 19 coulomb. So now what is here N? I told that N can be 1, 2, 3. So that means sometimes oil drop can absorb one charge, sometimes 2, sometimes 3. So that's why N can have any value. It can have 1, 2, 3 extra value. So this was the discovery of electron. Yes, any question here? Okay. So then with the help of these values, can you tell me what will be the mass of electron? From these two values, can we calculate the mass of electron? Mass of electron. So mass of electron, it can be calculated from E upon M ratio and charge of electron. So see, actually we have seen E upon M ratio of electron, how much it was? It was 1.67 into 10 raised power 11 coulomb per kg, right? And what was the charge of electron? Charge of electron, it was found to be minus 1.602 into 10 raised power minus 19 coulomb. Now, with the help of these two values, we can calculate the mass of electrons. See how to calculate the mass. So mass will be calculated like this. That is, mass is equal to E upon m ratio. Charge, that is E upon m ratio. Because what will happen here? E and E, they will just cancel and m will come up. So that is your mass. So that means you will just write here E, that is the charge. Charge is, its magnitude is 1.602 into 10 raised to power minus 19 coulomb. Now, when you will divide it by E upon m ratio, what is E upon m ratio? That is your 1.67 into 10 raised to power 11 coulomb per kg, right? 11 coulomb per kg. So that means coulomb and coulomb, it will get cancelled here, and kg will up. We will get the mass in kg. Now see here how to solve this. It is your 1.602. I will just divide it by 1.67. Now see, it was here 10 raised to power minus 19 coulomb. Then here it was 10 raised to power 11. When it will come up, it will become 10 raised to power minus 11. So when base R SAM power should be added. So when you will just divide these two, it will just come out to be 0.9109 into 10 raised to power. See, when base R SAM power should be added. So how much it will come? Minus 19 and minus 11. That is minus 30, right? So this is in kg. So now you can also write it like this. That is 9.109 into 10 raised to power minus 31 kg. So this is the mass of electron. Got it? This is very important that you should be able to calculate mass from this charge and charge upon mass ratio. That is E upon m ratio. And now you have to remember this value, that is 9.109, or you can also write it as 9.11. You can also write it as rounding off. You can round it off 9.11 into 10 raised to power minus 31 kg. Correct? So this is the mass of electron, which was actually found by here from the two observations, that is the charge and charge upon mass ratio. So you have to remember now the three very important things here. So what is one? One is the charge of electron. So I hope you have now got this charge of electron. Its value is how much? Minus 1.602 into 10 raised to power minus 19 coulomb. And what is the mass of electron? Mass of electron is 9.11 into 10 raised to power 10 to the power minus 31 kg. But sometimes if question is asked that what is the mass of electron in grams, it is in kg. So can you convert it into grams? I hope you have studied unit conversion in the first unit. Can you convert it into grams? See, actually we know that 1 kg, that is equal to 1000 gram, isn't it? So that means I can write 1 kg, it is my 10 raised to power 3 gram. So now what will be here? This is your kg. We have to convert it into grams. So what I will write? I will write 9.11 into 10 raised to power minus 31. Now kg is to be converted into grams. So I will just multiply it by 10 raised to power 3 gram. So when base R SAM power should be added here. So what will be the value here? 9.11 into 10 raised to power. It is minus 31 and plus 3. So it will be minus 28 gram. So this is the mass of electron in grams. Got it? Mass of electron, it's in grams. So another thing which we noted down here, that was charge upon mass ratio, that is E upon m ratio. So E upon m ratio, its value was 1.67 into 10 raised to power 11 coulomb per kg. 11 coulomb per kg. Correct? Yes. So now you will finally remember. Now, how can you define what is an electron? So how can you define what is an electron? So I will define it like this, that electron is that subatomic particle which has charge of, which has negative charge of 1 unit, which has negative charge of 1 unit. And what is that actually? Negative charge of 1 unit, that is minus 1.602 into 10 raised to power minus 19 coulomb, and has mass of 9.11 into 10 raised to power minus 31 kg. Now this mass is very, very small. So how much it is small? So you can write that is 1 upon 1837 times that of hydrogen atom. Got it? So it is very, very small mass. So this is how we can define what is an electron. So it is simply that subatomic particle which has negative charge of 1 unit, that is minus 1.602 into 10 raised to power minus 19 coulomb, and has mass of 9.11 into 10 raised to power minus 31 kg. That is nearly 1837 times less than that of hydrogen atom. So that means mass of electron, it is very, very small. So that is why mass of electron, it is neglected. So how you can now remember it? You can remember like this, that for example, if I will write here, this is my electron here. Electron is represented by this symbol E negative. Then let me write it as actual charge. So what is actual charge of electron? Actual charge is minus 1.602 into 10 raised to power minus 19 coulomb. But what is the relative charge? That means you have to tell the relative charge here, not the actual. Relative is taken as minus 1 unit, right? Similarly, if I will tell you that what is the actual mass of electron, so can you tell me the actual mass of electron? Actual mass, yes, it is 9.11 into 10 raised to power minus 31 kg. But if I will tell you what is its relative mass, relative mass, it is taken as 0, because I told that this mass is very, very small. It is neglected. It is taken as 0. Because it is, see, it is how much? It is 9.11, then it is 10 raised to power minus 31. So that means you have to divide it by 1, and then how many zeros? 31 zeros. So that means it will come very, very small mass. So that's why its relative mass is taken as 0. Got it? Have you got it?
Yes, sir.
Yes, exactly. Now, see how sometimes question is asked like this. Now, a very important question is that sometimes it is asked that what is the origin of cathode rays? So where these cathode rays actually come from? So can you tell me their origin, where they originate? Where these cathode rays originate? Yes, they originate from cathode, isn't it? Originate from cathode, right? Yes, they originate from cathode. Now, another question is here for you, that can you tell me what will be the charge of 1 mole? Can you tell me charge of 1 mole of electrons? So how to calculate the charge of 1 mole of electrons? So it is very simple. See, we know what is the charge of 1 electron.
Minus 1.602.
Charge of 1 electron, that is your minus 1.602 into 10 raised power minus 19 coulomb, right? It is that of 1 electron, but you have to tell the charge of 1 mole of electron. So 1 mole is how much?
6.022.
Exactly. So you will write 6.022 into 10 raised power 23, and then you will multiply it with 1.602 into 10 raised power minus 19. So that means it will just look like this. It will become 6.022, and you have to multiply it with 1.602. Then when bases are same, power should be added. So it is 23 and minus 19. That will be 10 raised to power 4, right? So when you just solve this, it will come out to be 96,475 coulomb, because we have to calculate the charge of 1 mole of electron. So that is nearly taken as 96,500 coulomb. That is nearly taken as 96,500 coulomb, and which is known as 1 Faraday. It is known as 1 Faraday. So I hope you will remember it. 1 Faraday is how much? So 1 Faraday, it is always equal to 96,500 coulomb. Got it? Yes, it is 96,500 coulomb. 1 Faraday. It is known as 1 Faraday. So that means the charge of 1 mole of electrons, it is 96,475, or you can approximately take it as 96,500 coulomb. So that is known as 1 Faraday. So have you written down this?
Yes, sir.
Yes. Now, are you having any question, any doubt in today's session? Then I will just repeat it, have a quick recap.
Sir, you wrote mass
Yes.
of one electron is 1 by 1837 of that of H atom. I don't understand what that is.
Yes. Can you repeat it again?
So you wrote mass of one electron is 1 by 1837 of H atom.
Yes.
I don't understand how.
Okay. I will tell you. See, what I told that the mass of electron is very small. Okay, I will write it here. See, mass of electron, I told it is 9.11 into 10 raised power minus 31 kg. Now this mass is very small mass, isn't it? Because it is actually 9.11, then you have to divide it by 1 and then 31 zeros. So it will come out very small. So that is why I'm saying that mass of electron is very small, and hence it is neglected, right? And hence it is neglected. So when I'm just neglecting the mass of electron, so that is why. So that is the average mass of electron, it's taken as 0, isn't it? Average mass of electron is taken as 0. Now see here, what is the mass? Can you tell me the mass of hydrogen? Mass of hydrogen atom. What is the mass of one hydrogen atom?
One name.
Can you tell me the mass of one hydrogen atom?
One user. One.
No, I am just telling the actual mass of one hydrogen atom. That is the relative mass. You have to tell me the actual mass of hydrogen atom, one hydrogen atom. Can anybody tell me among you that what is the actual mass of one hydrogen atom?
Sir, the point 1.007.
No, that is the relative mass. See, that is the relative mass of hydrogen, 1.008 or 1.007. That is the relative mass. That is the unified mass, or AMU. I am just telling the mass of one atom of hydrogen. That is the actual mass you have to tell. You have to tell me the actual mass of hydrogen atom. Do you know anybody knows? Have you not studied the mole concept? There we have used this concept, mass of one hydrogen atom. It is actually calculated with the help of spectrometer. We are having the instrument spectrometer, with the help of which we can calculate the mass of one hydrogen atom. So its mass is 1.675 into 10 raised to power minus 27 kg. This is the mass of one hydrogen atom, single hydrogen. Got it?
Okay, okay, sir.
Yes, this is the mass of one hydrogen atom, which is experimentally found with the help of spectroscope. I will write it here. The instrument is spectroscope, mass spectroscope, with the help of which we find this. Now tell me that is this mass greater than the mass of electron or less than?
Sir, it's greater than.
Exactly, it is greater than. So that is why I told that the mass of electron is 1/1837 times less than times that of hydrogen atom. Have you
Okay.
got it now?
Okay.
Yes. Okay, so anybody having any other question? Do you have any question, any other question? If you have any question, any doubt, you can ask. So see now what you have to now remember. You have to remember first of all that who discovered the electron. So electron was finally discovered by J.J. Thomson. It is the talk of 1897. And how it was actually got discovered by the experiment carried out by William Crookes. That is the cathode ray discharge tube experiment. And then I told that what is the charge of electron? It is minus 1.602 into 10 raised to power minus 19 coulomb. And then I told what is the mass of electron? It's 9.11 into 10 raised to power minus 31 kg. Or you can also convert it into grams. Then it will be 10 raised to power minus 28 gram. And then I told the E upon M ratio. So that is your 1.67 into 10 raised to power 11 coulomb per kg. And then I told that the actual mass is 9.11 into 10 raised to power minus 31 kg, but the relative mass is taken as 0. This is very important, that the relative mass of electron, it is very, very small. So that's why it's taken as 0. And then I told you that the actual charge of electron is minus 1.602 into 10 raised to power minus 19 coulomb, but the relative charge is taken as minus 1 unit. Got it? Then we have also calculated the charge of 1 mole of electron, that is your 96,500 coulomb. So that is known as 1 Faraday. I hope you will remember this. 1 Faraday is how much? So 1 Faraday is how much? Can you repeat it?
96,500.
Exactly, it is 96,500 coulomb. So I hope that you have enjoyed this class. Then let's continue tomorrow in the next session. Wish you all the very best. Have a nice day ahead.
Thank you, sir.
Thank you, sir.
Most welcome.